Good morning and welcome to our chapter on circles. Today we're going to be talking about different terms and vocabulary that are associated with circles, as well as discuss circumference of circles. The first term we'll talk about here is the center of a circle. Okay, so what I've done here is I went ahead and filled in these definitions. You can either pause the video and fill them in right now, or wait for me to go through them, talk about the notation, and then you can pause the video. So whichever way you prefer is totally fine with me. The first thing that I mentioned here is the center. The center of a circle is a point that is equidistant to all points on the circle. So I can name that point right there. That's the center. That is then, the center is the point A. So when we name a circle, we name it by its center. So this would be circle A. That would be the notation. Always name it by the center point. All right, a radius is a segment whose endpoints are the center and a point, any point that's on the circle. So I could start here from A, and any point I draw that would be on the circle, let's say I call this B, that's the radius. Now imagine how many different ways I could have drawn that radius. There's an infinite amount. The notation for a radius then, because it's a segment, we name a segment by its endpoint, and then we put little segment bar over the letters, 2 capital letters. Chords. A chord is a segment that has 2 endpoints that are on the circle. So for example, if I draw a point there, and I'm going to draw a segment and a point right there. Let's say I name this point C and this point D. That is a chord. Again, it's just a segment that has 2 endpoints on the circle. Next, we have diameter. A diameter is a chord that passes through the center. So it's a chord, but it's a very specific chord. It has to go through the center of the circle. So say I started here. That's my endpoint. I draw a chord, so it's got to have endpoints on both of its endpoints have to be on the circle, but it has to pass through the center. So the diameter, in this case, let's say I call that E and F. Our diameter here is segment EF. Now, hopefully you realize what the relationship between a diameter and the radius is. If I look at this segment right here, that's a radius. If I look from A to F, that's a radius. So the diameter is always going to equal 2 times the radius. Next, we have the circumference. And what the circumference is it is the distance around the circle. So if I had a tape measure that's very flexible, like those kind of paper ones that tailors use or whatever, I would see what the distance around the circle is. So remember, that's kind of like the circle's perimeter, but for circles it has a special name. It's called circumference. Now let's talk about pi. What is special about pi? Other than it being delicious, pi is what you would get. It's a number you would get when you take any circle's circumference, the distance around it, ran out of room, over its diameter. Any single circle, if you took those 2 measurements and you took circumference and divided by diameter, we would get pi 3.14156, I believe. So that's how you get pi. Or you could bake it. Just kidding. Next up here is the formula for the circumference of a circle. It's either C equals 2 pi r or circumference equals pi times diameter. And the reason that that's true is 2r is diameter. So either of those are the same thing, right? You could take 2 times the radius, which is the same thing as the diameter. Don't confuse that with pi r squared, which is the area formula. Always remember that area comes in units that are squared. If you're measuring area of a floor that you need carpeted, it would be in feet squared or yards squared. So that's how I always try to tell kids to remember the difference. It's not pi r squared, it's 2 pi r. And then another thing is a lot of kids do confuse it with 2 pi r squared. They'll combine those 2 equations. It's just 2 pi r. Last thing on this slide that we're going to talk about is exact answers, which are in terms of pi, versus approximate answers, which are going to be decimals. If you have an assignment or on an assessment, it says leave answers in exact form, do not press the pi button on your calculator. You are just going to take pi and bring it along for the ride, okay? It's just going to keep getting carried along throughout the problem and your answer. If it asks for approximate answers, that's when you would press pi. Okay, exact, you are never going to press pi. Sorry, I got a little choked up. So again, exact answers means do not press pi. You will have pi in your answer. Approximate answers, you will press pi on your calculator and then round your answer to whatever decimal it tells you to. All right, so here's our first example, and I will show you what I mean by exact versus approximate. So here it tells me the circle has a circumference of 27 feet. So the circumference, remember, is 2 pi r. Now the reason that I'm using 2 pi r instead of pi times diameter is because they're asking me for the exact radius. So what I'm going to do is I'm going to take this 27 feet and plug it in for the circumference. So 27 is going to equal 2 pi r. Remember, I am trying to get r by itself. So what that means is I have to get rid of what is attached to r by the inverse operation. The 2 and pi and r are all being multiplied, so I'm going to divide 2 pi away from both sides. Now that cancels on my right side, the 2 and the pi, and on the left, I am left with what the radius is, which is 27 over 2 pi. And now this is in feet because my dimension here was in feet. This next part is very important that you pay attention, and don't just assume that you're going to know how to type this into your calculator, especially if you have a graphing calculator. Because if you take your graphing calculator and you just type in 27 and then you divide and then you press 2 and pi, and by the way, pi is your second and then like kind of the exponent button above your division sign, that's where pi is. If you type this in, here's what your calculator is going to do. It's going to take 27 divided by 2, which is 13.5, and then multiply it by pi. Whereas here, if I'm approximating, I know 2 pi is 2 times 3.14. That's 6.28. 27 divided by 6 is not going to be the same thing as 13.5 times 3. That's going to be a much bigger number. So what you're going to have to do, because your calculator, if you type this in right here, it's going to do the order of operations. Left to right, it's going to do division, and then it's going to multiply. So in order for your calculator to know that the 2 and the pi are both in the denominator, what you're going to have to add is these parentheses. Right? Your parentheses, if you have a graphing calculator, are above your 8 and your 9. So that's where you open the parentheses, close the parentheses, so then you group those together so your calculator knows order of operations, it has to multiply 2 and pi together and then do that division. So go ahead, type this into your calculator and make sure that you do get this answer. If not, please ask your teacher tomorrow. Say, I don't know how to do this on my calculator, and we will be happy to show you. All right, next example. It says find the exact circumference of the circle to the left, exact meaning I will never press the pi button on my calculator. That doesn't mean I'm not going to use my calculator. It just means I am never going to approximate pi. It's going to be there in my answer. So when you have to find the circumference of a circle, you need either the radius or the diameter. If you have the radius, you could get the diameter. If you have the diameter, you could get the radius. But you need one of those because circumference is 2 pi r, aka pi times diameter. So when I look at this circle, I don't have the radius. I don't have the diameter, right? This would be the diameter. This right here would be the radius. What I do have, however, is a right triangle. And as soon as I see a right triangle, my mind always goes to Pythagorean theorem or right triangle trig. Can I use one of those methods to get the missing measurement that I need? And in this case, yes, I'm going to use Pythagorean theorem. So remember, Pythagorean theorem is leg squared plus leg squared equals hypotenuse, which I call d squared. Okay, so working through this, I get 256 plus 900 equals the hypotenuse, aka the diameter squared. I get 1156 equals d squared. D is going to end up equaling 34. If you did Pythagorean triples, which you aren't required to do, this is an 8 15, 17, where I took each side and doubled it, giving me an answer of 34. So now the circumference, I'm going to use pi times diameter. And the way I'm going to write this is instead of writing pi times 34 to the right, typically we write it as 34 pi, and then my units are in centimeters. Next part of these notes is about congruent circles. Congruent meaning if I took one circle and placed it on top of the other, what's going to make them be exactly the same size? And how that would happen is they must have congruent radii. Radii is the plural of radius. It's not radiuses, it's radii. So as long as two circles have the exact same radius, that's all it takes for them to be congruent. Next definition here is concentric circles. Concentric circles are ones that are on the same plane, meaning like on the floor, let's say, and they will have the exact same center. They share a common center. So all of these circles here, pictured, these green ones are concentric because this point is the center. All right, these overlapping problems. These are my favorite ones of this section. Also ones that kind of give students sometimes a little bit of trouble. But once you get the hang of it, they become easy peasy. All right, so here we have two overlapping circles, circle X and circle Y. They tell me that the diameter of circle X is 22. Remember that the diameter is the distance all the way across through the center. So I don't even have a diameter drawn here for circle X, but what I do have is the radius. So I know that from X to Z then, if the entire diameter is 22, that would make my radius equal to 11. So I'm going to label that in my picture. Okay, now same thing goes for circle Y. Circle Y, they told me the diameter is 16. I don't have the diameter. I have what I have drawn in is the radius. So this is going to equal 8. Now the last piece of information that they gave me here is that WZ, this segment right here, is equal to 5. So what a lot of kids do, kind of not thinking about this problem correctly, is they'll just add all of those pieces. But if I add 11 plus 5 plus 8, I am really adding this segment way too many times. So what I have to do is think to myself, okay, if from X to Z is equal to 11, I know XZ is also equal to XW plus WZ. Okay, so I'm going to fill in numbers. I know XZ is 11 equals, I don't know XW, that's my unknown, plus I know WZ is 5. So if I subtract 11 minus 5, I'm going to get what XW equals, and that is 6. Okay, so I know this little segment here is 6. Same goes here for ZY. I know WY is equal to 8. I also know that WY is equal to WZ plus ZY. WY is 8. We figured that out in the beginning. WZ is 5 plus ZY is my unknown. So ZY is going to equal 3. Now, to get this entire segment, I'm going to add XW, 6, plus, oops, I changed my highlighter color. That's okay. WZ, 5, plus ZY, which is 3. So that entire segment, XY, is going to equal 6 plus 5 is 11 plus 3, 14. Okay, so the work that I showed is maybe unnecessary for a lot of you. You could just say, okay, if the whole thing here, I know from here to here is 11, this took up 5, what's left for XW? That's fine too. You could do that part in your head, not a problem. All right, so the next part of these notes is talking about inscribed versus circumscribed, because a lot of times you're going to be given problems where they're going to use these words and you're going to need to know how to draw the figure. Without being able to draw the figure, you're going to have a really difficult time with the problem, maybe even impossible. Okay, a polygon is inscribed in a circle if all of its vertices lie on the circle. So what that would mean, if I had a circle, and this is not notability, so I can't draw it as nice, all of its vertices would be on the circle. So I'll just draw some sort of pentagon here, or no, I'm going to draw a quadrilateral. This quadrilateral is inscribed. in the circle. Okay? A polygon is circumscribed about a circle if each side of the polygon is tangent to the circle. What that means, tangent means each side intersects the circle at one point. So if I draw a circle here, I'm just going to draw a definition or a picture of what tangent means. This line is tangent to the circle because it only intersects the circle in one point. Okay, so what I've drawn here is a polygon that's circumscribed about the circle. Circumscribed means it's on the outside. So what I tried to do here, I drew the circle first and then I drew a quadrilateral around it. The quadrilateral is circumscribed about the circle. The circle is inscribed in the polygon. Okay, here the circle is circumscribed about the polygon. The polygon is inscribed inside the circle. So try to keep those two straight. I think what helps is inscribed. If something is inscribed, it's the shape on the inside. Circumscribed, outside. All right, so let's do this example number 4, which is a challenging problem. You are going to see problems like this, so don't avoid them when they come up in homework. Make sure you practice them so that you get the practice that you need. Given a square with an area of 36 square feet is inscribed in a circle. Okay, so what that means is I have a circle and there's a square inscribed. So that means all of its vertices have to touch the edge of the circle. Again, because I'm not using notability, this is more difficult for me to draw nicely. If I had notability, I could make this actually look really good. This does not look great. So what we're going to do is make a sketch, find the circumference of the circle. So remember, the circumference of a circle is either 2 pi r or pi times diameter. So I need one of those here. Now, if the area of my square is 36, remember the area of a square is side times side. It's side squared. If I know the area is 36, I know that each side of this circle is 6 units long. Okay, so focusing in here, this is 6 and this is 6. Now, many kids think, oh, okay, then that's the diameter. It is not. These 6's don't go through the center. The center of the circle is right there. So in green here even, you are given a hint. A diagonal of the square is going to be the diameter of the circle. So if I was to connect those two, I do have the diameter. That's green. However, by saying I do have it, I don't have the value yet. However, I can find it because recall that a square has 4 congruent angles. So I can find the diameter here by either using special right triangles. This is a L root 2, so the diameter would be 6 root 2, or I could do Pythagorean theorem. So I would do 6 squared plus 6 squared equals diameter squared, and I would end up with the same answer. I'd get 36 plus 36 equals diameter squared, 72 equals diameter squared. Simplify square root of 72, there's a perfect square root of, or there's a perfect factor of 36 in there, that would be 6 root 2. So now they want my answer in exact form. Circumference is diameter 6 root 2 times pi. I have no decimals in my answer. Even if I had something like 4/5 pi, I would leave 4/5. Or if I had 1/3 of pi, I would leave it as 1/3 pi if I wanted it to be exact. Here's a little brain teaser for you. If you, grid paper can be used to find area. So the first triangle up top, if I rearrange the shapes in a different form, the area should be the same. So can anyone think about where this hole down here came from? Why is it there? These are all the exact same shapes. If you look at their sizes, they don't get smaller in the second picture. So what accounts for that missing piece right there? That should not happen. All right. That brings us to the last slide, which is just what your homework is. So homework is day 1. It'll be due the next class period along with these notes. Thank you so much for watching. Have a great day. Bye.